So in this video we'll talk about Pascal's law. Now this is quite important. Okay, in Pascal law you are frequently asked numerical problem, and so we'll deal with a numerical problem and the statement. So it's very important. So let's start with the statement. So it states that pressure exerted in an enclosed vessel is equally transmitted in all directions. Now we have quite possible diagram with this, and you may be asked the diagram and asks you to identify the given principle associated with the diagram. So we have this kind of diagram, the plastic container like that. So the liquids are coming out when we apply pressure. The liquid comes with equal pressure. So next kind of diagram, which is quite very popular and quite asked frequently, is the diagram of this one. So we have two piston over here. So we have two cylinder, small cylinder, large cylinder, and the last cylinder is fitted with large piston. Okay, so we have certain load over here and we apply. Now one thing we have to notice is that on the small cylinder, okay, on the small cylinder we always apply effort. So effort is applied over here. So the effort is applied over here, and the load, okay, the load, the heavier one, is kept on the larger cylinder, and this is filled with liquid, definitely. Okay, so there are other kind of diagram. It may be associated with the same law. So this is the next diagram which you will often say. So there are four pistons. Okay, there are four pistons. So this is also related with Archimedes principle, and sometime though it has not been asked in S.L.C up to now, but there is a next diagram like this. There's a piston over here. Okay, so it goes like this. Okay, and we have piston over here, piston over here, piston over here, and the liquid is filled inside. So these are some diagrams that are associated with Pascal's law. So write any three applications of Pascal law. So application means the use of Pascal law. So Pascal law, it is used in hydraulic. Okay, so hydraulic lift, hydraulic jack, hydraulic brake, like on. Okay, so next question. So we are given the diagram and ask the question associated with the given diagram. The first question can be like this: identify the given instrument. What is given over here? So this is hydraulic. Okay, this is HYDRAULIC, hydraulic lift. Okay, so second question that we can link on this: write the two laws on which this device work. Okay, so two laws. Now the first law, we can easily say that will be Pascal's law. Okay, so the first law is Pascal's law. Now what about the second law? Okay, now second law is associated with the nature of metal kept over here. So we fill this with water or liquid. Now since the liquid are incompressible in nature, that means we cannot compress liquid. So you can say that liquid cannot be compressed. Okay, liquid cannot be compressed, or you can say liquid is incompressible in nature. If you have kept air over here, this wouldn't work. Why? Because air can be compressed, and since air can be compressed, the pressure won't be it won't be supplied to other direction. That means the force won't multiply. It won't this doesn't work over here. So two laws on which this device works are Pascal's law and liquid cannot be compressed. So next question we can be asked: what is the role of water, okay, in this device? So what does the water do? So I have already said that now water can be compressed. Since water can be compressed, it helps to transmit the applied pressure. Okay, the pressure that is applied over here, let's consider this pressure to be P1. So the pressure that is applied P1, now this pressure transmit because of the liquid over here. So liquid helps to transmit the applied pressure. Okay, so the role of water, that is, it helps to transmit the applied okay, the applied force, or you can say pressure, okay, force or pressure. So next question it is asked in exam is that prove that hydraulic lift is a force multiplier. So it's quite easy. Okay, now let's do it. And the question where you are asked to prove something or derive something, in physics, three things you must consider. First, you have to make a figure, okay, and second thing, first is figure, okay, don't forget about the figure. So second thing, you have to consider the language. Now whatever figure you have made, now what we have made that figure, okay, so just we have to write a simple language based on the figure. And third will be the involved mathematics, okay, the involved calculation and the mathematics, the part of derivation or the proof. Okay, so we have already made the figure, so let's write the language. So how do we write the language? Now the given figure, it is a hydraulic lift. Now consider F1 is the force that is applied on the small piston, and F2 be the load, okay, kept on the large piston having area A2. So this is the language we'll be simply writing. So this is it. Let F1 be the force applied on the small piston having area A1, and F2 be the force on the large piston of area A2. So let P1 and P2 be the pressure, developed on these pistons. Okay, now according to Pascal's law, we have the concept P1 must be equal to P2, or now in the place of P1 we can write over here F1 divided by A1 is equals to F2 divided by A2. Now, okay, here I have a question. Now what's our target? What should we prove? Now question says that prove that hydraulic lift is a force multiplier. See, we have applied the force that is F1, and we should raise the load, or we have to carry the load, we have to lift the load, that is F2. Now we have to prove that F2 must be greater than F1. So this is our target to prove. Okay, so we have the relation F1 by A1 is equals to F2 by A2. Now let's try to find the value of F2 from here. The A2 will go over there, so it goes over there, it becomes multiply. So I'll write over here A2 divided by A1 into F1. Okay, I have just rearranged them. It's all right that you can write here multiply this, but I have just kept them in separate. Now if you see, this is equals to F2. Now as we can see from this that A2 is greater than, now since A2 is greater than A1, okay, now we know that definitely this is the area of large piston, area of small piston. Now if this is, for example, let's consider the area is double, so double, then the ratio will become 2. This is 10, this is 5 and the 5 to the 2, so we have to multiply 2 into F1, so F2 will be 2 times greater than F1. So therefore we can write that F2 is greater than F1. Hence we have proved that this device is a force multiplier.